Hello. In today's video segment, we are going to walk through the steps in a hands-on activity that will employ some basic data reclamation techniques to recover data from a USB stick. And in my previous video on preparing your Linux system for forensic analysis, we did show that from the Windows File Explorer and from the graphical File Explorer in Linux, there indeed showed no data on the disk. It had been erased. But we are going to use one of the three basic acquisition pathways for data discovery, physical analysis, to reclaim data from this disk. Physical analysis is the gold standard in digital forensics, since with this method, the data on the media is replicated entirely. There is a downside. With every upside, there is always a downside. The downside is it takes resources and some time because you are creating a bit-by-bit replica of this media. But we are going to use some basic open source tools available in the Linux world, and you will see that via this lab, you will be able to conduct physical analysis on a small sample, because this is a not large USB stick to use as a test case. If you are walking through this lab on your own system from the lab instructions that we see here on the right-hand side, there are a few things to take note. One is there is a special character in the Linux world, the pipe character, and it is very different from a slash or a backslash, so take heed to the pipe character. Another thing to keep in mind is the lab was originally written for a classroom environment where there was a special user account set up named CCT231 and a special password, cyber. If you're doing this on your own computer system, then you should make sure that you're using an administrative level account or an account that has access to sudo or account elevation, and then you would just use that user's name and password. So let's get going. I've opened the terminal or command line interface on Linux Mint, and as you can see in the lab, I've done that by clicking the terminal icon, opening the terminal. So once in that command line interface, I am going to explore a bit. So I want to change directories to something named /dev and then get a listing of the disk media. So let's do that. All right, we can see that we have a single disk SDA and some logical partitions to that media. Okay. Now, we are to insert the USB stick that either has been given to you if you're in the class or that I have here in my hand. And that media is inserted. Initially, that media is going to be recognized by my Windows system, my host, and we can see that that was recognized here. We can also notice that the Windows recognizes that the folder is empty. I will dismiss that. Then I want to make sure that my Linux system knows about this disk, so I'm going to go to the Devices window at the top of the Oracle VM hypervisor controller and click on the USB media, and it will take just a minute, but that USB will be detected. You can see there's volume information but no files. I merely want to. There. All right, so now it is time to reissue this listing of the disks. We see something a little bit different. And you are asked in the lab to discuss those differences. You'll be able to do that now. Linux has a command called dmesg, which allows one to see activities recorded in the kernel ring buffer, and also has a command mount. And mount shows those file systems that are currently mounted or accessible in the operating system. So let's look at that mount command, and we're going to use grep to see what's there. So I'll give you just a minute to have a brief look at that output, because you need to then say, what can you learn from looking at this output? We're now going to create a folder in a temporary directory that Linux and all Unix-like operating systems have, /tmp, and then we're going to make a directory for our analysis. And in fact, change directories to that location. Once we are here, it is time to create the bit-by-bit replica of the USB drive. And we are going to use a special tool called DCF-LDD. If you do not recall DCF-LDD from the prep video, you can use the Linux man page system. Just type MAN space DCF-LDD to display the manual page for this utility. Then you will be able to answer the question, what is DCF-LDD? So let's get going by putting in this exact command line that will be used to create the digital replica of the file. IF stands for the input file, which is the media in our USB drive. We saw earlier that that was from the location dev SDB1, and we want the output file to be this special directory that we just created. And since it's a store and go named on that USB, we will name our file go.dd. That file extension name of DD is purely of my own discretion. Just chose it because of the ending name in my tool, so that later, should I go back and examine this file, I'll have some recollection of its purpose. So let's study what we put in. If you're doing this at home yourself, make sure that everything is typed exactly as it should be. And once we are certain, we hit the Enter key. Now, because we used account elevation, SUDO, we must put in our user account's password, whatever your user account's password is, and the tool will begin. We can see that block by block that the data is being written from the input file of /dev/SDB1 to our output file location in that /TMP directory. Now, some number of minutes later, that bit-by-bit replica has finally been created. We can see that 58,944 records were read in, and that same amount were read out. We can feel pretty good about that, but it is important in the forensic analysis discipline to be able to prove either to a client, perhaps to a jury, that evidence has not been tampered with and it hasn't been modified in any way, either intentionally or unintentionally. So to further that objective, we look at step 15. We are going to create hash signatures for both the USB original disk and for the bit-by-bit replica we just made. So we're going to use a tool called SHA-1SUM, and we will apply that to our go.dd replica, creating an output file we'll just call go.sha, and we can put two commands on the same line by separating them with a semicolon, and so we will possibly do that. And create a second file, card.sha, from the original media dev/SDB1. So let's do that. You notice if you run out of screen display space that your text just wraps around. Pay really no attention to that. Make sure you don't hit the enter key until you are completely finished with the command, and then hit enter. The commands take a moment because they are doing a mathematical calculation to create this hash signature on both of the files. So we see that we got this permission denied message for accessing the /dev/SDB1. That means that we have to use account elevation to run that particular command and access that drive. And that's as it should be, right? Not everybody should just be able to access the external media. So, and we have to enter our password to show that we have the privileges to do account elevation. And again, we'll just wait a moment. So let's look at what we have. Back at our command line, let's do a long listing, and we see that we have the digital replica that we created. We see how large it is. That is consistent with the fact that it is a bit-by-bit copy of our USB disk. And then we have our two .sha files. Well, in Linux, we can look at the contents of a file with the cat command. So I will cat each of those SHA files. And at this point, you should be able to take a look at that output so that you can go to question 17 and answer that question. What can you learn by looking at the contents of go.sha and card.sha? And then move on to 18, looking at the manual page for the strings command, so that you can explain what this utility is able to provide for you as it relates to forensic analysis. If you do not have a Linux command line interface in front of you to issue the man space strings command, it is possible to use a standard Firefox or Chrome browser and enter into the search box Linux man strings, and you should be able to find a manual page output. Now we're going to move on and use a tool called photorec, which we installed during the video on preparing your system for forensic analysis. And again, you're asked to use the manual page utility to find out what photorec is and what it does. You can also use Google again as described. So let's open photorec. Photorec space go.dd to analyze that replica. We'll see a screen that looks very similar to this one, and we'll use proceed on the screen to move forward. Well, I'm going to clear the screen first. Proceed is already highlighted. We'll accept that default and accept the second default. And we want to look at the whole partition. And please select a destination to save the recovered files. Do not choose to write the files to the same partition they were stored on. So that is an admonition, but we're going to just choose the current directory where we are located, which happens to be /tmp/recovery/recov. Press C and allow the process to run to completion. So I will press C when the destination is correct. And the process begins and will continue. We can see some interesting things happening. You should watch. Read the screen for yourself. You'll want to see what has been created. So we will use the Linux ls command to explore the directory that has been created. We'll look at that right now. So I will quit and quit and quit. We have a new directory. If you are working in Linux Mint like I am, you will see this Carolina blue color, sky blue, and that will indicate that it is a directory. So I'm going to change directories using CD into this new directory and list what is in that directory. And lo and behold, we have several files. At this point, we can refer back to the lab and see that it may be easier to analyze what has been created by actually using the GUI of Linux Mint. So if you have Linux Mint, you can open up the graphical user interface by looking for the file folder icon on your panel, and we will use the up arrow to go to a parent directory until we are at the level that we can find TMP. I'll double click just like I would do in Windows, and we can move down to Recov, and the RECUP_dir.1 that was created. And oh my, there are some files. These are files that were reconstructed by the tool named photorec from that bit-by-bit replica of the USB that we copied. You'll want to list the names of the files that you see. I'll double click each one so that you can see it. We'll just take a look at each one, and you can answer any questions. So we have a file that ends in JPG. We have a file just named by the system F0019794 with a PDF extension. Interesting. We have a second JPG. And a third JPG. And something that is an extended markup language report. And we'll slowly go through that. Photorec did not create a .ini file in this case, so you do not need to discuss that. And this final question about sleight of hand hasn't been taken into consideration with this particular recovery. So there you have it, the steps using one of the open source tools available called photorec, along with other readily available Linux tools. And we've been able to recover some data from an otherwise erased USB. Stay tuned for more labs where we'll explore other utilities.